I'm Talal Barkat. I'm going to be explaining blockchain databases today. Let me start with a story. Picture yourself at a grocery store holding a box of fresh organic tomatoes. You notice a QR code on the packaging. So you scan it with your phone and bam, you can see the entire history pop up on your screen, where the tomatoes were grown, how they were harvested, how they were transported, even details about the quality checks all along the way. Every step of the journey of the tomato, from when it was harvested and planted to where you are seeing it in your own store, was recorded securely and transparently in a blockchain database. Why this matters? Well, it ensures no one along the supply chain can tamper with the data. So basically, no fake labels, no altered timestamps. You, as a consumer, can trust what you can see. And that's just one example of how blockchain databases are transforming industries. In today's presentation, I'm going to break down what blockchain databases are, how they work, and why they're such a big deal. Blockchain databases can sound intimidating at first, but you have to imagine it as a shared Google Doc. In a traditional database, there's usually an admin, which is one person or authority who controls the document. They can decide who edits, views, or deletes data. But in a blockchain database, everyone has a copy of that document. Every change, every entry is visible to everyone on the network. If someone tries to cheat or change an old entry, everyone will know immediately, and the network will reject that change, basically. And here's where it gets even cooler. Blockchains don't rely on visibility. It also uses something called cryptography. Think of it like a digital lock on every piece of data. Once something is written in the blockchain, it's locked forever. No edits, no deletes, just pure transparency and trust. So basically, you can say blockchains are Google Docs with the addition of cryptographic security. Let's bring this to life with a visual. Imagine a series of blocks, like little digital containers. Each block has three key things: the data, the hash, and the previous hash. The data could be transaction details, records, or any digital information. The hash, think of this as a unique fingerprint for the block. And the previous hash, connects this block to the one before it, creating a chain basically. Now, here's the magic. If someone tries to change data in block 2, its hash changes. But wait, block 3 has block two's old hash saved as its reference. This mismatch will immediately alert the entire network, and the tampering attempt will fail. This interconnected structure is what makes blockchain databases so secure and trustworthy. Every block depends on the integrity of the previous one. It's like building a tower of Lego bricks, where each brick has a unique code that must match the brick below it. If one is altered, the entire tower collapses. When explaining something like blockchain, it's easy to get caught up in the technical stuff of it all. But the goal here isn't so fancy. It's to make you understand every step of the way. I'll walk you through each concept one at a time and keep things straightforward. You can consider blockchains as a secure, transparent data storage at the end of the day. All right, now that I've set a foundation by understanding what blockchain databases are and how they work and why they matter, now it's time to shift gears and dive into the heart of our presentation. Up until now, we've seen what blockchain databases are through examples, analogies, and visuals. Now, we've seen how they ensure trust, security, and transparency. But to really appreciate their impact, we need to go deeper. So now I'll explain the comparison of traditional databases, the key features and the challenges, real-world applications, future trends. By the end of the day, by the end, you'll have a clear understanding of why blockchain databases are more than just hype. They're the parad they're the shift in data management. So a blockchain a blockchain is a decentralized digital ledger of transactions distributed across a network of computers. The key features being decentralization, immutability, transparency, and security through cryptography. The differences between traditional databases and blockchain databases. Usually, traditional databases are centralized, they're editable, and they're more prone to hacking. Whereas blockchain databases, they're decentralized, and you can only add to it, meaning append only, and it's cryptographically secure. How blockchain databases work? For once you have blocks, as we explained, they store data, transactions, or records, and so on. A chain, where the blocks are cryptographically linked. A consensus mechanism, where it validates data, basically proof of work, for example. And then decentralization, where data is distributed across nodes. Types of blockchain databases. You have four types of blockchain databases. One being public blockchain, which is open and anyone can join, for example, Bitcoin, Ethereum. Two, private blockchains, where there is restricted access, such as Hyperledger. Then hybrid blockchain, that being the third type, combines between public and private aspects. And four, consortium blockchain, which is controlled by multiple organizations. What are the advantages of blockchain databases? The security. As it's cryptographically encrypted, it ensures the protection of the data. The transparency. As I explained in my analogies before, every transaction is visible on the ledger, and it will be there permanently. Immutability. Data cannot be altered once recorded. As I said, they'll be there permanently. And then traceability. It tracks the entire data lifecycle. Challenges of blockchain databases. There are sometimes scalability issues where you have slow transaction speed, energy consumption, high computational costs. There's complex integration. It's difficult to merge with existing systems, and legal and regulatory uncertainty. Sometimes there are unclear regulations. Uses Use cases of blockchain databases. You can use it in finance, where there are cryptocurrencies such as Bitcoin and Ethereum, now replacing the old currencies such as dollars, any type of actual currency or country currency, let's say. Then supply chain, transparent tracking. You can track food trust, like IBM Food Trust, for example. They trace where the food comes, where it starts, where it leads, how it got to your store at the end of the day. And then healthcare, secure health records, such as guard time. And then voting systems, fraud-proof voting platforms. IBM Food Trust blockchain, for example, it tracks food products from farm to table. It ensures transparency and reduces fraud. The future trends in blockchain databases. There are green blockchain solutions, integration with AI and IoT, interoperability between chains, and wider enterprise adoption. Conclusion. Blockchain databases combine security, transparency, and decentralization. While they face challenges, their potential applications are vast, and the future is promising as technology matures and adoption increases. Thank you for joining me on this journey. through the world of blockchain databases. I hope you see why this technology is so groundbreaking and how it's already changing industries worldwide. If you found this helpful, don't forget to like and comment, and you can leave any questions in the comments where I can answer them. Thank you.